Okay, welcome back. And now we're going to talk about the second derivative test. So up to this point, we've introduced a lot of things that we can look at to find maximum and minimum values, right? So with the first derivative test, we looked at whether the function was increasing or decreasing. Well, now that we've got this idea of concavity and we can test to see over intervals whether the function is concave up or concave down, well, now we can use concavity to help us find or determine whether a point in an interval, in an interval represents a max or a minimum by looking at the second derivative. Because as we've seen, is if we can find the critical points, we know that extrema only happen at critical points. So we find the critical points and then we test those points using the second derivative of the function. Well, if it's a maximum value, it'll be concave down, right? If it's a minimum value, you'll get concave up. Okay, so that leads us to the second derivative test. Okay, so here's how it works. So Theorem 3, which is the second derivative test, says, suppose we have f prime of c equal to 0. So the first derivative is equal to 0. So in other words, c is a critical point, right? And also we know that f double prime, or the second derivative of f, is continuous over an interval that contains c. Okay? So, in other words, one of the things that we were talking about before was twice differential, right? So, if this is true, if this is satisfied, then one of these three is going to happen. Either the second derivative at c is going to be positive, which is going to tell us it's a local minimum at c. Or the second derivative is going to be negative at c, which is going to tell us it's a maximum point because it's concave down at that critical point. Or the second derivative at c is going to equal 0, which tells us that the test is inconclusive. So we don't know. So at this point, what we have to do is go back to the first derivative test and test it at that point. Okay? But that is the second derivative test, and now what we'll do is we will do some examples and see how it works. Have a great day.